Section 11.7. Today we have two objectives. The first one deals with triangles, and the objective is I can find the ratio of areas of two triangles. And the second objective deals with similar figures. I can apply the relationship between scale factors, perimeters, and areas of similar figures. So starting out with triangles. So we can relate the areas of two triangles depending on what we know about about the triangles. So comparing areas of triangles. So if we're working with triangles, there's three things that we want to check. The first one is if the triangles have the same height. And it says if two triangles have equal height, that's the key, equal height, then the ratio of their areas equals the ratio of their bases. Okay? So if they have the same height, in other words, their the altitudes to the opposite side are the same length, then we just set up a ratio of their bases, and that equals the ratio of their areas. The second possibility is that they have the same base. Okay, so it says if two triangles have equal bases, then the ratio of their heights equals the ratio of their areas. Okay? And the third possibility is if the two triangles are similar. If two triangles are similar, then the ratio of their areas equals the square of their scale factor. Okay, so example. Okay, so let's say I have this picture and I basically have two triangles. I have this triangle and this triangle, and I know that this is 8 and this is 3. But these two triangles have the same height, because if I drop an altitude from here, that is the height of triangle 1, it's also the height of triangle 2. So the first theorem says that the area of triangle 1 is to the area of triangle 2 as the area of their bases. So the ratio, or as the ratio of their bases. So the base is 8 to 3. So the ratio of their areas equals the ratio of their bases. Okay, so that's example 1. Example 2. Okay, so let's say I have this picture. Where this is triangle 1, this is triangle 2. The height of this one is 9, and the height of this one is 5. Okay? So these two triangles have the same base, and therefore the area of triangle 1 is to the area of triangle 2 as the ratio of their heights. So that's going to be 9 over 5. Okay? And the third one said if the triangles are similar. So if I have something like this, where I know this is parallel to this, and this is triangle 1 and this is triangle 2, this is 3 and this is 6, then these are similar because we know that these angles are congruent by vertical angles, and then I know that this angle is congruent to that angle, so therefore the triangles are similar. So when you're using similarity, you have to find the scale factor and square it. So the ratio of the area of triangle 1 to the ratio of the area of triangle 2 is, well, the scale factor is 3 to 6, but then we have to square that. So it's 9 to 36 or 1 to 4. Okay, so that's when you're looking at triangles, you're looking for the same height, the same base, or similar triangles. Now that takes us to similar figures. How do we relate things in similar figures? Okay. Okay, so if we're looking at similar figures, not just triangles, but any figures that are similar, it's this. If the scale factor of two similar figures is A to B, then the following is always true. The ratio of their perimeters is also A to B. So the ratio of the perimeters is the same as the scale factor. But the ratio of their areas is the scale factor squared. So it's A squared to B squared. So, and it's easy to remember because area is always squared. So you always just square it. Okay? So, for example, the scale factor of two similar figures is 3 to 5. Find the ratio of their perimeters. Okay? Well, the ratio of the perimeters is just the scale factor, so it's going to be 3 to 5. Find the ratio of their areas. Well, the ratio of the areas is just the scale factor squared, so 3 squared to 5 squared, which is 9 to 25, which doesn't reduce. Okay? And so if you know the figures are similar, you can set up proportions to solve for unknown parts. Okay? So just remember, if it's triangles, you can relate the bases, the heights, or if they're similar, their scale factor. If it's similar figures, it's the scale factor, and if you're wanting the area, it's the scale factor squared.